In this video, we are going to talk about different ways that we can measure and determine the overall impact and effect of a toxicological exposure. And so we're going to start by talking about the four primary types of toxicological effects. And all of these effects mostly have to do with the duration of exposure and the level of exposure and when the effects actually start to manifest themselves. When do we start to see ill effects show up? So we'll start with acute effects. Acute effects are rapid effects. These are things that develop quickly and can happen in a number of different ways. Acute exposure can cause injury, it can cause disease, it can cause even death. But the key term here is that it develops rapidly. So what we see in this is that we're going to see rapid development of symptoms when an acute exposure is noted. Chronic exposure, chronic health effects. These are injuries, diseases, death caused by exposure, but instead of happening rapidly, where we're talking about within a few hours of exposure, we see ill effects. These are effects that develop over a period of days or weeks or even months. And so that's probably one of the most common misconceptions about chronic health effects. The place where we tend to see this term the most often is in lawsuit commercials. Uh, are you dealing with chronic effects of mesothelioma associated with exposure to asbestos? It's probably the most common one out there now. Chronic is about days and weeks and months. The effects that are usually associated with mesothelioma, asbestos exposure, other types of workplace-related injuries don't fall into this category of chronic. They actually fall into a later category, latent effects. So latent effects are injuries or diseases caused by exposure to a substance that doesn't really show up until years have passed, an extensive period of time has passed. Now you'll notice I did skip over one here. The one I skipped over is something called a short-term health effect. Short-term health effects primarily are ones where we see kind of like an acute effect, where the person is injured or gets some kind of mal effect rapidly, but recovers rapidly as well. And so in short-term health effects, what we tend to see is a very fast onboarding and a very fast offboarding. Whereas with acute effects, usually the damage is more permanent and lasting. And notice that the word death doesn't appear anywhere in here because obviously in death there is no recovery. So there is that impact that you have to look at as well. The next thing that we're going to want to look at are the factors that actually impact the degree of toxicity. And there are 5 such factors. So um, usually with toxicity, we talk about the dose being the end all and be all. And that's only part of the equation. There are actually 5 things that we can look at. One of them is dose, the quantity of substance that is ingested or inhaled or absorbed. But there are also factors like duration. How long were you exposed to the toxic material? How quickly does it get into your bloodstream? So with this one, we're usually talking about avenues of mode of entry. How did it get into your body? Because rates for absorption and inhalation are going to be much different from each other. We can also look at age and health, and sometimes how quickly your body is able to process toxins can have a significant impact. And then finally, just individual sensitivities. What are some things that might impact certain kinds of individuals but not others. So the next thing that we're going to look at is, measuring toxicity. So when it comes to toxicity and dosage kinds of ideas, there are a number of different exposure limits that are given. Some of them are set by local agencies, some of them are set by governmental agencies, some of them are set by other workplace enforcement agencies. And these are some of the more common ones: the short-term exposure limit, the permissible exposure limit, the immediately dangerous to life and health level, and some others. Let's take a look at just some overall measurements of toxicity. So the first one we're going to look at is something called the LD50. LD50 is short for lethal dose, 50% kill. And this number is derived from laboratory experiments. So we look at a toxic material, we give varying doses of that toxic material to laboratory animals, usually rats, and we monitor how well the animals are able to handle the toxic dosages. And the LD50 represents the dosage that actually kills 50% of the population that it's given to. And there's a time parameter associated with it. It varies um, by toxin and by animal. Now, we usually express LD50s in terms of milligrams of substance per kilogram of body mass. And this is to take into consideration one of those things that is really important in the measurement of toxicity, and that is, well, some people are bigger and some people are smaller, and the same dosage might impact each of those people differently. Well, when we level it down to looking at things based on body mass, we can negate some of those effects of big people versus small people. Very similarly oriented is something called the LC50. LC50, the lethal concentration, 50% kill, is the concentration of a substance that kills half of the subjects in that exposure time. And this is used primarily for gases, liquids, and solutions. You'll see these used for LC50 because usually these are parts of mixtures. And so as a part of a mixture, we're talking about units in parts per million by volume. And so one way of looking at parts per million would be milligrams of substance per liter of solution. That is one determination of parts per million. Now, what about TLV? Threshold limit value. This is the upper limit of a concentration where an average healthy person can be exposed to this concentration all day, every day, and not suffer any kind of serious health effects. We see this most often with common environmental toxins, things that we would encounter just on a normal everyday kind of basis. And these are, again, the maximum limit. So if you see a TLV value, what you're really thinking about there is, this is my maximum exposure and still be safe. So if I got this dose every day, all day, I wouldn't expect to develop any kinds of ill effects from it. Again, we see this most often with substances in air, so parts per million is the common way to go. And again, that's milligrams of toxin per liter of air. We can also see it in terms of a different metric unit, milligrams per cubic meter. This is a little bit bigger. A cubic meter is 1,000 liters. But it is nonetheless another method of expression. PEL Permissible exposure limit. This is a common value for workplace, and it is a time-weighted average of a toxic substance that people can be exposed to continuously for 8 hours. So this involves a time-weighted average calculation. Time-weighted average can be calculated by taking the exposure concentration multiplied by the time exposed and basically summing those for every time that you are exposed and then dividing it by 8 hours of a workday. So however much we get exposure to, we just take that and we multiply the exposure times the amount of time exposed plus, so this is for exposure number 1. This is for exposure number 2. And if there is an exposure number 3, we would add that, and exposure number 4, we would add that as well. The next one is STEL. STEL is the concentration that you can be exposed to continuously for 15 minutes without suffering irritation, chronic, irreversible tissue damage, or narcosis. Um, any kind of ill effects that would impair your ability to do your work efficiently. So STEL puts a very short limitation on the toxic exposure, 15 minutes. Now, as a result, in a 15-minute exposure, you're going to find different limitations here than you would on the previous, where we're talking about, things that might be able to be spanned out over an entire day. Next on the list is IDLH, the immediately dangerous to life and health level. This is the atmospheric concentration of any substance that poses an immediate threat to your life or causes irreversible or delayed adverse health effects, or interferes with your ability to escape from the room in a 30-minute time period. So IDLH is definitely the most serious of the groups. And we see this in terms of how quickly you have to respond. And it's kind of your get the heck out of the room level. So when you're in the workplace or otherwise, look for these different kinds of values, especially if you know that you're going to be dealing with things that are potentially dangerous or toxic. Now, there is one more exposure level that we need to discuss, and that is the REL, the recommended exposure level. Now, REL is still a time-weighted average. The only difference is that it's a time-weighted average over a 10-hour work period instead of an 8-hour work period. And the reason why this was done primarily was to account for there are certain professions where an 8-hour workday is just not a feasible amount of time worked. If you're in the construction industry, if you're in the medical field where 10 and 12-hour shifts are far more common, trying to distill everything down to a normal 8-hour workday just doesn't make a whole lot of sense. But the equation that you use to do the time-weighted average is exactly the same. So notice the equation is incredibly similar. We've got our time-weighted average, we've got our exposure concentration multiplications, and we're adding together each exposure, but we're dividing by 10 hours instead of just 8. And so those are all of the different exposure limitations and dosage calculations that are associated. We'll talk more about specific toxins next time.